Hello, my name is Lindsay Broadway. This is Physics 2212, Experiment 1, Charge Tapes. So the purpose of this lab is to understand how charges interact with each other and how charges are transferred from one object to another. So when we ripped the piece of tape off of the tape stuck to the table, we saw that the electrons from the piece of the tape that was stuck to the table transferred onto the tape that was ripped off, making it negatively charged. Some models and physics principles that we used were Coulomb's law. You can see that in the bottom right-hand corner. And then the force of gravity, which is mg when an object is close to the surface of the Earth. And Newton's third law, which is equal and opposite forces. And so a preview of the lab is that the tapes repel each other. So when you suspend B and hold A up to it, since they are like charges, they repel, and then B is in a state of equilibrium. The system is tape B, and the surroundings are Earth and tape A. And the initial conditions are that B is hanging at rest, so the initial velocity of B is 0, and also the final velocity of V will be 0. So for the experiment, we found that the length of the tape was 0.18 meters, given that 1 gram or 1 meter of clear tape corresponds to 1 gram. Then we found that the mass of our tape was 0.00018 kilograms. And we also measured the distance between tape A and tape B to be 0.024 meters. And then given that the magnitude of the force of gravity is equal to mg, we multiplied m that we calculated above and the gravitational constant to be 0.001764 newtons. And then as you can see on the right, the free body diagram. So since the tape is hanging at rest, then we know that the forces must cancel each other out due to Newton's third law. So we know that the magnitude of the force of gravity is equal to the magnitude of the electric force. So that is equal to 0.001764 also. And then using Coulomb's law, we can calculate Q because that's the only unknown because we have the D above. And we found that Q is equal to 1.063 times 10 to the negative 8 coulombs. Or that's the magnitude of Q. In reality, it'll be negative because it's negatively charged due to the excess of electrons. And then, so for the first model, we made this model to be a point charge. So we let the tape kind of act as one charge instead of a distribution of charges throughout a line. So the M is what we found, the G is the constant, the D is what we found in the lab. And then we solved for the force of gravity, and then I made the blue particle at the bottom, the charge tape, in the red at the top be the tape that was suspended. And then the arrows show the force of gravity and the force of the electric field. The electric field, I made a function here, E field, and that is just kind of a laid out coded system to solve for Q like I did, or to solve for E like I did in the previous section. And then as you can see, it prints out that the magnitude of the electric force is equal to the magnitude of the gravitational force, which is correct, as we found in the lab. So then the second model was, instead of using the tapes as a point charge, we used them as a line of point charges. On the top left, you can see just kind of initializing everything. I used the same E field function as I did in Model 1. And then on the right, top right, I set the top tapes and the bottom tapes to be line charges. And I made the bottom tape the origin of our coordinate system, and then the top tape I made the distance above it. And then the for loops kind of just show how iterating through each of the point charges in the top tape and the bottom tape to get the electric forces for each point charge, which are the green arrows. And then the white arrow shows the net electric force, and the yellow arrow shows the net gravitational force. So the what if the signs were switched essentially, so negative was positive and positive was negative, what would change? Nothing would change. Like charges still repel and opposites still attract. So none of the observations would change. And then for the y, basically as you can see, the magnitude of the electric force is different for the line of point charges here. And the line charges show a smaller Q as it accounts for the distribution of charges throughout the tape. The closer value to the real value would be the line charges, because these points are distributed over a distance in real life and it's not just a singular point. In conclusion, some things that account for error are inaccurate measurements just of our distance of our tape, and also some faults in experimental procedure. So if we held the tape unsteadily and measured the distance wrong between the tapes, and also pulling the tape off of the table to transfer the electrons. Thank you.